This lesson is on utility expenses. That's Unit 11, Section 1. And in it, we're going to learn how to compute the cost of electric, gas, oil, and water for the home, how to compute the cost of using specific appliances for specific lengths of time, and how to compute the time it takes an energy-saving appliance to pay for itself. Some key terms in this lesson are utilities, which is electricity, natural gas, and/or heating oil and water services. Meter, the device used to measure usage of various utilities. Watts, the unit of measure for electricity. Watt hours, the amount of electricity used in 1 hour. Kilowatt hours, equivalent to 1,000 watt hours. Cubic foot, which is the volume measure for sale of water and gas. Volume, which is the amount of space occupied by certain utilities. CCF, which is the volume equal to 100 cubic feet. And lastly, rational function, which is an algebraic fraction where both the numerator and denominator are polynomials. So, how much will it cost to run the utilities in your home? Name some ways that you use energy in your daily life. Do you pay for the energy used in your home before or after it is consumed? Well, first of all, some ways you use energy are when you shower, when you use transportation, whether it's your own vehicle or some other vehicle, when you turn on the lights, when you turn on the heat. These are all instances where you're going to be using energy in your daily life. And then, secondly, do you pay for the energy used in your home before or after it is consumed? And this is always after it is consumed. They check the meter and then they charge you based on the amount that you have used. So now let's look at electricity. What requires electricity in your home? How is it measured? What about solar? Basically, all the appliances in your home typically use electricity. These are lights, heating, etc. How is electricity measured? Typically, it is measured in kilowatt hours, okay? That's how many kilowatts are used in an hour. And then what about solar? Well, there's various ways of getting solar energy. There's solar farms, which you can often see in different locations. There's also rooftop solar, where you can put solar on the roof of your home, or actually, in the case of Worcester Academy, it's on the roof of some of the buildings here. So now let's look at heat. What are some of the sources of heat? How is it measured? Are there sources that are not utilities? And what about air conditioning? Well, some of the obvious sources for heating are gas, oil, wood, electricity. These are all different ways that we can heat our homes. And how is it measured? Well, it depends on the source, okay? If it's electricity, it's kilowatt hours. If it's gas or oil, it could be by volume. So it depends on the source. Now, are there sources that are not utility? Yes. For example, wood or pellet stoves. These are not considered utilities, but they are used to heat homes. And then what about air conditioning? Well, typically air conditioning is sourced from electricity. Air conditioning units run on electricity. So again, it's electricity usage that determines the amount of air conditioning that you have. So now let's look at water, okay? We all need water in our homes. So what are some of the sources and how is it measured? Well, depending on where you're located, your source of water could be a reservoir, it could be a private well, or anything of that nature. And how is it measured? Typically by volume, or in this particular case, cubic feet. So let's look at some examples. First of all, Tom's October water bill listed 2 meter readings. The previous reading was 3,128 CCF, okay? And the present reading is 3,141 CCF. How much water did Tom's household use during the billing period? So all we basically have to do here is just subtract the two readings. Take the present reading, 3,141, and subtract the previous reading from it, 3,128, and you come out with how much you use, which is 13 CCF. All right, so now let's look at another example. In this case, we're looking to determine how much electricity is used. Well, electric meters typically have these dials on them. And in this particular case, we want to see, well, what do these dials actually read? Well, the first thing you got to do is you got to look and see which way the dials are reading. For example, this first dial on the left, if you go counterclockwise, okay, it's increasing. And you notice it's not quite up to 1, so therefore this first reading is 0. The second dial, however, if you look at it closely, reads clockwise, all right? So you can see on this dial, it's just past 9, so therefore this reading is 9, all right? The next dial, again, goes counterclockwise. It's between 5 and 6, so therefore this reading is 5. The next one goes clockwise. It's again between 5 and 6, so this also goes 5. And lastly, this one goes counterclockwise. It's between 1 and 2, so we read 1. So it's 0.9551 kilowatt hours. So here's another example. A certain electric mixer requires 125 watts. How much would it cost to run the mixer for a total of 90 minutes at a cost of 10 cents per kilowatt hour? Okay, so let's see how much it's going to cost. Well, the first thing we're going to do is, if it runs for 90 minutes, all right, let's see how much of an hour that is. So we divide 90 by 60, and we come out with 1.5 hours. Next, we want to take and multiply 125 watts times 1.5 hours, and we come up with 187.5 watt hours, okay? So it's utilizing 125 watts in an hour and a half. That comes out to be 187.5 watt hours. Well, electricity is measured in kilowatt hours, so we must take that figure and divide it by 1,000 and come up with 0.1875 kilowatt hours. Well, that's how electricity is measured. And notice in the problem, it costs 10 cents per kilowatt hour. So we take this 0.1875, we multiply it by 0.1, and we come out with this value here, 0.01875, or about 1.9 cents. So not a huge amount of money that it costs to run that electric mixer for 90 minutes. Well, now let's look at example 4. Depending on the climate, utility usage can vary according to the seasons. Electric bills can be higher in the summer due to air conditioning use, and gas and oil usage can be higher in winter due to heating needs. For this reason, some utilities offer balanced paying. This evens out the monthly cost of utilities to make the homeowner's payments predictable, okay? So rather than having a huge bill when they make a certain delivery or you use a certain amount, they spread it out over the whole year. Last year, the Ross family spent $3,336 for electricity. They are opting to use balanced billing for next year. What will their monthly payment be? So in order to calculate this, all you do is simply take their annual utility cost, which in this case was $3,336, and divide it by 12 months, because we're going to spread it out over the whole year in monthly payments, all right? And that comes out to be $278 per month. All right, example 5. Energy savings often pay for themselves. This means that the savings in energy usage can equal or offset the cost of the item after a certain number of years. The Thompsons' old water heater costs them $455 per year to run. The new one they purchased for $1,240 will save them 31% annually in energy costs to run it. How many years will it pay for itself? All right, so let's calculate their savings, okay? So we said that they're going to save 31% annually in energy costs. So if I take 31% of 455, which is what the old water heater cost to run, we come out with $141.05 savings per year, okay? So each year they're going to save $141 from what they would have paid if they had their old water heater, all right? Now, it costs them $1,240 to buy this new energy-efficient water heater. So if I take the $1,240, divide it by the $141.05 savings per year, we come out with approximately 8.791, or it will pay for itself in about 9 years. So in 9 years, the savings per year will equal the cost of the water heater, and anything after that will be considered profit. Now example 6. Michael purchased a desktop computer with a monitor for $2,500. Michael always leaves both in the power up mode. On average, his make and model costs a total of $96 per year to run in electricity costs when it is constantly on. What is the average yearly cost to own and operate this computer system at the end of 5 years? All right, first of all, let's look at the cost of the computer. The cost of the computer can be represented by this function right here, 2,500 plus 96x. Well, what is that saying? It's saying that it costs $2,500 to buy the computer. So that's a fixed cost one time. Then each year, it's going to cost $96 to run it and keep it on. So the cost of the computer is the cost of the computer plus the average cost per year in electricity costs. All right. So now, we want to find what is the average yearly cost to own and operate this computer at the end of 5 years. All right, so we're going to take and create a new function, a of x, and that's simply equal to the cost of the computer, c of x, divided by the number of years, okay? So c of x is simply equal to 2,500 plus 96x, which remember is the cost of the computer plus the average cost per year in electricity. Divide that by 5, okay, which is the number of years, and the average yearly cost to own and operate the computer at the end of 5 years is $596. That's taking into account the initial cost of the computer plus the cost of the electricity each year.